coordinate, the stresses are like in the your last this that cause सब मूड खराब हो जाता है. Polynomial of the different degree, we study sigma x, sigma y and tau xy. So in the polar coordinate the stresses are sigma r is equal to 1 upon r del phi upon del r plus 1 upon r square del square phi upon del phi del theta square. Del theta is equal to del square phi upon del theta square, del r square, sorry. And tau r theta is equal to 1 upon r square del phi upon del theta minus 1 upon r del r del theta. It can be write del by del r of 1 upon r del phi upon del theta, where phi is the stress function of r and theta. Phi is the function of r and theta, like in the our last case it was function of x and y. So in the polar coordinate the x and y can be replaced by the, this is the equation number 38. Now, if R and S external forces are 0, then they should satisfy the equation number 38. In the Cartesian coordinate, we studied that sigma x is equal to sigma x cos square alpha plus sigma y sin square alpha plus 2 tau xy sin alpha cos alpha, and tau is equal to tau xy cos square alpha minus sin square alpha sigma y minus sigma x sin alpha cos alpha. This was the equation number 13. Now, to convert it into polar coordinate, you replace alpha with theta and sigma to sigma r and sigma to sigma theta, where the angle is theta 90 plus theta. Here it is theta, for this it is 90 plus theta for the sigma r, sigma theta. So, as we replace, we are getting sigma r is equal to sigma x cos square theta plus sigma y sin square theta plus 2 tau xy sin theta cos theta. Similarly, sigma theta, if you make theta to 90 plus theta, I think nobody is known what is the value of cos 90 plus theta and sin 90 plus theta. cos 90 plus theta. Anybody? In sin 90 plus theta, I am replacing theta by 90 plus theta and here also 90 plus theta to get the value of sigma theta. This is equation A, and tau r theta is equal to sigma y minus sigma x sin theta cos theta. This is tau r theta cos square theta minus sin square theta. This is the equation we got from the equation 13. We already studied. We are replacing theta. For this theta, alpha is replaced by theta. Here alpha is replaced for the 90 plus theta and tau r theta. So we are getting the value directly from this. Now, for the polar coordinate, if it is x axis, it is y axis, any point A can be represented by here x and y. In the polar it is represented by r and theta. Also from this triangle, r square is equal to x square plus y square. From the right angle triangle, r square is equal to x square plus y square. So differentiate this with respect to r. So 2r dr by dx is equal to, with respect to x, 2x plus 0. With respect to x, we are getting 2r, differentiation of r square is 2r, differentiation x square 2x, and with respect to x it is 0. So dr by dx is equal to 2x upon 2r, means x upon r. X upon r, from this sin cos 10, anybody? It is cos theta. Similarly, if we differentiate this with respect to y, you will get 2r del r by del y is equal to 0 here and here 2y. So we will get the dr by del y is equal to y upon r, which is sin theta. From this triangle, y upon r is the sin theta. Also, from this triangle, tan theta is equal to y upon x. So theta is equal to tan inverse y upon x. Formula for tan inverse is if theta is equal to tan inverse z, then del theta by del z is equal to 1 upon 1 plus z square del by del x of z. This is the formula for tan theta. If tan theta is equal to z, then formula for del theta by, here it is our z is the y upon x. So theta in our case is equal to 1 upon 1 plus y upon x square 1 upon z square del by del x upon y upon x. Solving this, we will get, taking the LCM, x square upon x square plus y square and here y minus x square, because differentiation of 1 upon x del by del x of 1 by x means x to the power minus 1, so it comes minus and it is x square. So finally x square, we can put this as a r square, x square plus y square is equal to r square. I already written somewhere here in this triangle axis, so we can replace this by r, so we will get minus y upon r square del theta by del x. So we got the value of these things. Now, in the that it was f, no, not phi, and in the polar it is phi. So del f upon del x is equal to, we can write del f upon del r into del r upon del x plus del f upon del theta and del theta upon del x. And del square f upon del x square, we can write del by del x of del f by del x. So if you open, we will get the del square f upon, and here also it cancels, so you will get the del f by del x, here also you will get the del f by del x. So these are equations we can write. Now, here del f upon del r, as we proved here, and del r upon del x, del r upon del x, we already proved cos theta. So we will get the cos theta del by del r minus sin theta upon r del by del theta. Del r upon del x and del r upon del y, we put the value from the here. We already proved. So we can put the value. Now, this is the value of del f upon del x. Further, value of del by del x. Now we can write this. Cos theta del by del r minus sin theta upon del upon r del by del theta, and find del f by del x here. cos theta del f by del r minus sin theta upon r del f by del theta. Because if you replace this by cos theta for del f by del x, you will get this. You replace del theta by del x for sin theta, you will get this. So, for this we put the value of this and this. So, we are getting this. So, if you open the bracket by multiplying these things, finally you will get cos square theta del square f upon del r square sin square theta minus 1 upon r del f by del r 1 upon r square del square upon del theta square minus 2 sin theta cos theta del by del r of 1 upon r del f upon del theta. This is the equation D. Similarly, del f square upon del y square you can write, means you can prove from here. Similarly, as we find out del f by del x square x, we can find out the del square upon. Similarly, by writing this, putting the value of these two brackets, you will get sin square theta del square f upon del r square plus cos square theta 1 upon r del f upon del r 1 upon r square del square f upon del theta square plus 2 sin theta cos theta 1 upon r del f by del theta. This is equation E. And for del square f, अरे पेन गया भाई एक तो, ब्लैक, del x del y, you will get sin theta cos theta 1 upon r del f upon del r plus 1 upon r square del square f upon del theta square plus 2 sin theta cos theta del by del r 1 upon r del f upon del theta. This is f. From the previous lectures, we know del x is equal to del square phi upon del y square minus rho g y. Cy is equal to del square phi upon sigma y is equal to del square minus rho g y, and tau x y is equal to minus del square phi upon del x del y. It was the equation number 29 in the from the your previous lectures. Now putting the rho g is equal to 0, the derivative on the left hand side of DEF, left hand side of the DEF, you have the three equation DEF, become sigma y, sigma x and tau xy respectively. And the expression on the right hand side of DEF can be substituted for this stresses component in the right hand side. Okay. So, in the exam sometimes we ask the question sigma x, prove that sigma x plus sigma y is equal to sigma r plus sigma theta. This type of question comes in your exam. So, del square f upon del x square is equal to cos square theta del square f upon del r square plus, we already we proved in the DEF. I am writing the same. Here you can see this I am writing the same thing I am writing here. Sin theta, cos theta, del by del r of 1 upon r del f upon del r. Also we proved del square f upon del y square is equal to sin square theta del square f upon del r square plus cos square theta 1 upon r del f upon del r plus 1 upon r square del square f upon del theta square plus 2 sin theta cos theta del by del r of 1 upon r del f by del r. We already proved these two equations. If you add this equation, you will get here del square f upon del x square plus del square f upon del y square is equal to del square f upon del r square common and in the bracket sin square theta plus cos square theta. Yes sir, right. Again here same thing, del of del r. Yes, right. Sin square theta plus cos square theta, and here it is cancel, so you will get the 0. So in the next step you will get del f upon del square and 1 upon r del f upon del r 1 upon r square del square f upon del theta square into 1. This was the equation D as we studied in this lecture, DE. Now this is G. This is equation G. Now, should I remove this or I will write there? Okay, no problem. By replacing the alpha with theta and 90 plus theta, we are getting the equation, and for the tau sigma x and sigma y we are getting sigma this equation in the previous. So we can get this is sigma r cos square theta plus sigma theta sin square theta minus 2 tau r theta sin theta cos theta, and sigma y is equal to sigma r sin square theta sigma theta cos square theta plus 2 tau r theta sin theta cos theta. मैंने इक्वेशन आपको लिखवाया था ए इक्वेशन लिखवाया था, उसके बाद एक इक्वेशन बी था. शुड आई रिमूव दिस द टॉप वन?
सर लेफ्ट साइड में सबसे नीचे वाली इक्वेशन वो विजिबल, ये जी के नीचे वाली इक्वेशन विजिबल दो.
अच्छा, ये वाली
जी के नीचे.
अच्छा, जी के नीचे. नो, आई जस्ट पुट दिस इज वन del square f upon del square r square into 1 here 1 plus this I have put 1. So this is the same. I eliminate this and eliminate this, and this is 0. So this is the same equation with the sin square theta plus cos square theta is always 1. आया समझ में? हाँ. तो एक रह गया था, मैंने आपको लिखवाया था सिग्मा आर इज इक्वल टू सिग्मा एक्स कॉस स्क्वायर थीटा प्लस सिग्मा वाई साइन स्क्वायर थीटा प्लस 2 टाउ एक्स वाई साइन थीटा कॉस थीटा. ये अभी मैंने लिखवाया था आपको. सिग्मा थीटा इज इक्वल टू सिग्मा वाई साइन, यू रिफर योर नोट्स जस्ट नाउ. sin theta cos theta and tau r theta is equal to sigma y minus sigma. For equation 13, in equation 13 I replace the alpha with the theta, so and alpha one time with 90 plus theta in the equation 13. So we are getting, we'll got the value of sigma r sigma theta and tau r theta. Sin theta cos theta 2 tau x y sin theta cos theta. Now If again we replace here sigma r with the sigma x and sigma theta with the sigma y, so we will get sigma x, that equation will get. If you replace with sigma r to sigma x, sigma theta to sigma y, and this is xy, we will get this equation. Therefore, I come there. So, you will get the sigma x, sigma y and tau xy is equal to sigma r minus sigma theta. Same, these three equations will get in this way by replacing the sigma r and y, sigma x, sigma y like this. Sin theta cos theta plus tau r theta cos square theta minus sin square theta. This is equation B. This was the equation A and this is the equation B. So, in proving this may come in the exam, okay, prove this. So, you just write the equation 13. From equation 13 you replace alpha by theta and 1 and alpha again with 90 plus theta and xy with r theta. So, you will get the equation A, and again your equation in A you replace these things. So, sigma r with sigma x and sigma theta with sigma y and tau r theta with, you will get the equation this. So, you will get the equation B. Okay. Now, again you add these two equation you add, sigma x plus sigma y, sigma x plus sigma y, what you will get? If you will add sigma x plus sigma y, what you will get? We already did this in the equation, in proving the equation sin square theta cos square theta 1 रखा था अपन ने अभी. The same thing will repeat here. You add these two. If you will add, you will get this sigma r common sin square theta plus cos square theta, and here this will cancel out, and this here sigma theta sin square theta plus cos square theta. So, sigma x plus sigma y is equal to, this is 1, this is also 1. So, sigma theta. We proved. Very simple. If you remember the equation 13, you can reach to this equation. Okay, now equation number 24. I already repeating again and again that this subject is connected from the previous notes. This is the continuous subject. If you will miss anything, any class, you will be unable to understand the next one also. Now, it is in the book, it is the page number 30, and in अरे राम, ये रेड पेन भी गया हुआ है. सर दोनों रखे. कहाँ रखे? एक ही रखा अभी तो. Now, so in the equation 24, if you remember, refer your notes, if you are since regular, so you find that this is del square upon del y square del x plus del y is equal to 0. This was the equation number 24. Now, if you replace this by g and you replace this by, as we proved, sigma r plus sigma theta, we just proved sigma x plus sigma y is equal to sigma r plus sigma theta, and this is also we proved in the equation g, this is del square upon del r square. The subject is easy if you want to learn by heart, otherwise it is very difficult. If you make the formality to attend the class, it is difficult, and if you attend by heart, it is easy. Just I have replaced the equation g and that proved equation, you can make this f something. So, I am getting this equation. This is equation number 39. Again, we can put the value of sigma r and sigma theta, as we already found. Value of sigma r and sigma theta we found, you find your notes. So, we can replace this by 1 upon r del square phi upon del r square plus 1 upon r square del square phi upon del theta square plus del square phi upon del r square. This is the equation. And I already request you to come offline for my subject, but you are not understanding the thing, what I can do. From this, various solution can be find out. We will use this equation to solve the things. If you are able to see this, can you see this? Can you read this? Huh? The top one question. Can you read the top one? क्यों? टेक्निकल. हेलो, ये दिखाना है मुझे. How can I show this? थोड़ा सा गड़बड़ हो गया, अभी थोड़ा पीछे लीजिए. हाँ, ओके, नाउ इट इज, नाउ यू कैन सी. ठीक है, अभी ठीक है. स्टूडेंट्स, क्वेश्चन नंबर बी, it is question of the 12 marks. I am going to prove this. It is very simple. You take the screenshot or you can write. For the case of axial symmetrical stress distribution, taking the general solution of the compatibility equation. It was the general solution of the compatibility equation we just studied. From Q is equal to A log R plus BR square log R plus CR square plus D, calculate the maximum circumference stresses in the thick cylinder of internal radius Ri and external radius Re subjected to uniform inside pressure Pi and external pressure Pe at the inner and the outer surface of the cylinder. Okay, should I remove this?
Okay.
You note the question? Noted? Question is noted? क्या हुआ? सुनाई नहीं दे रहा.
स्क्रीनशॉट ले लिया सर.
ले लिया स्क्रीनशॉट, ओके. Before that, yes, you start. After equation 39, we'll prove something. Now you have these equations in your notebook. We'll use this. Okay? We'll use these equations. You write down the equation 39 again. I need that. Equation 39. क्या हो रहा है भाई? पेन सब खत्म हो रहे हैं. नहीं, वो धीरे धीरे पुराने हैं ना, एक एक खत्म हो रहा. ब्लैक हुआ, फिर ब्लू हुआ, फिर यस. डेल स्क्वायर अपान डेल आर स्क्वायर प्लस 1 upon r del by del r. So be ready for the question, 12 number question. This I shown you in the paper. By using this equation, you can solve this. If you know the equation number, you just write equation number 39 and you can start that question. Okay. Is this visible with the red? Huh?
Yes, sir.
Okay. Is equal to, this is equation 39. Just we proved. Now you write down, when the stress function depends upon R only. When the stress function is depends upon R only. And if I ask you the equation, prove the equation of compatibility, then you prove the previous one. So in the case of if depend upon the R only, theta is 0. So what you will get? What you will get if it depends upon the R only? Depends upon R and theta is 0. So what you will get here? Simple, d square upon dr square. If there is a one variable, del transfer to d. Previously there are two variable r and theta, so it was del. But if here it is the only one variable r, theta is 0, so it convert into the d. So d square upon dr square plus 1 upon r d upon dr. What about this? Anybody? 0. Yes. Here d square phi upon dr square. This is not theta, this is phi. 1 upon r d phi upon dr plus this is theta. So this is 0. Okay, agree? If the stress function is depend upon the one r and not depend upon the theta, you will get from 39 this equation. Agree? Agreed or not?
Yes, sir. Yes, sir.
Okay. Now you open the bracket. Just multiply the things, one with this with this and this. Just opening the bracket. So You start opening yourself also. What you will get? First term what you will get? If you multiply this by this, if I write 1, 2, 3, 4, so 1:3, 1 multiplied by 3, what you will get? Oh, del 4 phi upon del r square. Simple. Del 4 phi upon d, sorry, not del, d4 phi upon dr 4. Sorry, here also r square and r square, you will get the 4. Now, multiply the 1:3. What you will get? 1 multiplied by 3. D square upon dr square, bracket 1 upon r. You cannot simply multiply because differentiation with the r and r is here. So you have to write like this. This is 1:3. This is 1:2. Hey, 1:3, and this is 1:4. The second one. 1 2 3 4 लिखा ना मैंने, क्या लिखा है? 1 2 3 4. So 1:2, and this is 2:3. 2 into this 1 multiplied by the 4, so it is 1:4. Now the next, multiply this with the 3, 2 into 3. Yes. So you will get 1 upon r dq phi upon dr cube. dq phi upon dr cube. Okay. The last one, multiply 2 by 4. What you will get?
1 upon r square. D square phi.
Yes, 1 square d square phi and dr square. Yes. Now you have to solve this. Multiplication, differentiation of the multiplication of the 2. क्या होता है? Differentiation of the multiplication of the 2. First into differentiation of the second. There is the rule. There is a rule for the differentiation of the multiplication of 2. The first term you should remember. So first term multiply by the second. So dq phi upon dr cube. Okay. And in the second case, second into differentiation of the first. So second means d phi upon dr, and differentiation of the 1 upon r. First, in the first case, first term into differentiation of the second. In the second time, second into differentiation of the first. So differentiation of 1 upon r क्या होता है? You can write this r to the power 1 minus 1 also. You can replace 1 upon r by r to the power minus 1. Yes. So you will get, in this case, I will write this together. This is 1 upon r तो बाहर था ही शायद ना, हाँ 1 upon r into differentiation, हाँ d5 into differentiation of the r to the power minus 1. This is like this. So you will get d square upon dr square r to the power minus 2. Yes. और minus 1 यहाँ आ जाएगा. It is like this. This is the basic we studied in the previous classes. So after differentiate these two terms you will get, and finally will get the equation here, d4 phi upon dr4. This is the homework for you to come to this conclusion by rearranging these terms. So we will get d4 upon dr4, 2 upon r dq phi upon dr cube minus 1 upon r square d square phi upon dr square plus 1 upon r cube d phi upon dr is equal to 0. This is equation number 40. By doing this small differentiation, we write this thing, and adding these we combined, so you will get this equation. This is the terms for r, this is for r square, and this is for r cube. Because 1 upon r is the common, and this r to the power minus 2 you will write in the this. In the down 1 upon r square you will write like this, multiply this 1 upon r, you will get the 1 upon r cube, this term. Now you write down something. We are starting that question. Move fast. So you can write, this is an ordinary differential equation. This is an ordinary differential equation. I am talking about the equation 40. This is an ordinary differential equation which can be reduced to linear differential equation. This is an ordinary differential equation which can be reduced to linear differential equation which with constant coefficient Are you writing? You are writing or not?
Yes, sir.
This is an ordinary differential equation. For this exam question, you can start from here or even from the 41. I am writing the equation 41 which is given in the question. You can start from that. I just explain how it comes. So, this is an ordinary differential equation which can reduce to linear differential equation with the constant coefficient by introducing a new variable r is equal to e to the power t. R is equal to e to the power t. In this manner, the general solution of the equation 40 becomes phi is equal to A log R, which is given in the question itself. So don't worry about proving this, it is given in your paper. So we are starting the question paper solving this from this, okay, which has 4 constant A, B, C, D, agree, which has 4 constant A, B, C, D. Now again, this is your mind test, that differentiation of the log R or something, what you will get by differentiating the log, because we know sigma R is equal to this and sigma theta this and tau R theta this. So what is the sigma R? One upon R del phi upon del R. Sigma R is equal to 1 upon R del phi upon del R plus this. So del phi upon del R क्या होगा? Differentiate with respect to R. इसका क्या होगा डिफरेंशिएशन? लॉग आर का डिफरेंशिएशन क्या होगा विद रिस्पेक्ट टू आर? 1 upon R. Okay, so you will get A upon R. The second one, multiplication of the two. So B is common. R square का फर्स्ट इंटू डिफरेंशिएशन ऑफ द सेकंड क्या होता है? अभी किया आपने, लॉग आर का क्या होता है? 1 upon R. अरे बी तो है ही कांस्टेंट. नाउ दिस इज द मल्टीप्लीकेशन ऑफ द टू. तो फर्स्ट टर्म डिफरेंशिएशन ऑफ द सेकंड, डिफरेंशिएशन ऑफ द लॉग आर इज 1 upon R. एग्रीड? Now second term into the differentiation of the second, what you will get? 2R. Yes. Now for the third term, CR square, differentiation of CR square, what you will get? R square, 2, yes, 2CR. And what about D? 0. But for the sigma R, it is 1 upon R. So what you will get? Sigma R. Sigma R is equal to 1 upon R del phi upon del R. So from here you will get sigma R is equal to क्या मिलेगा?
1 upon R into ये differentiation.
हाँ तो फिर क्या आया? पहली टर्म में करो 1 upon R से A upon R स्क्वायर प्लस B R 1 upon R से करेंगे तो क्या होगा अंदर? हाँ कैंसल हो जाएगा. 1 ये R तो पहले ही यहाँ कैंसल था, पहले ही एक ही R बचा था और एक और अंदर R भेजा तो 1. प्लस 2 log r, और यहाँ क्या बचा 2c. दिस इज इक्वेशन 42a. Now for sigma theta is equal to del square phi upon del r square. So again you differentiate this once to get the del square phi upon del r square. So what you will get? A upon r का क्या होगा? A upon r square with minus sign. Agreed?
Yes, sir.
B में क्या है अंदर? R का 1 हो गया. उधर नहीं. Again there are two terms. So multiplication of the two, r into log 2r. log r, 2r कहाँ से लिखा मैंने ये? 2r तो मल्टीप्लीकेशन में है था. यस. सो इसका तो कर लिया अपन ने. नाउ दिस इज द मल्टीप्लीकेशन ऑफ द टू एज वी डिड इन द प्रीवियस दिस हियर ओनली. तो फर्स्ट टर्म इनटू डिफरेंशिएशन ऑफ द सेकंड. तो क्या आएगा? फर्स्ट टर्म 2r समझ लो, 2r. देन डिफरेंशिएशन ऑफ द log r कितना होगा? 1 upon r. अब दूसरे में क्या करेंगे? log r इंटू डिफरेंशिएशन ऑफ द 2r कितना आएगा? 2. So sigma theta is equal to del square phi upon del r square. You will what you get? Minus a upon r square plus b 3 plus 2 log r plus 2c. This is equation number 42c. Agree?
Yes.
And tau r theta is the 0. If you solve, this comes 0. Tau r theta, it becomes 0. If you put the value of these things, del phi upon del r or something, you will get the tau r. Here d by dr of 1 upon r, you will get the 0. Now you write down something, few lines. Now we have to find out the constant b and c. Otherwise, yes, you must find out the constant b and c. Now if it is given in the question internal pressure, external pressure, okay, so you go through that question, you will find the question was like this. If the internal radius is given a, external is b, internal pressure is pi, internal pressure. External pressure is what was the external pressure in the question? External pressure PE, it was given in the question paper. If there is a hole at the origin, other solution, then uniform tension and compression can be derived from the equation 42. From the equation 42. एंड इक्वेशन 42 कौन सी है जो अपन ने निकाला? सिग्मा आर इज इक्वल टू ए अपान आर स्क्वायर बी 1 प्लस 2 लॉग आर प्लस 2c. सिग्मा थीटा इज इक्वल टू डेल स्क्वायर 5 upon डेल ए माइनस ए अपॉन आर. दिस वाज द इक्वेशन 42. दीज थ्री इक्वेशन वाज द 42. A B C. I write this A B C. Tau r theta is 0. So 42 A B C means equation number 42. It is given in the book. Taking B as the 0. Taking capital B is the 0 constant. So what you will get? Sigma r is equal to, putting B is equal to 0 in that equation 42, sigma r, putting B is equal to, yes, sigma r is equal to A upon R square plus 2c. And for sigma theta, yes, minus A upon R square plus 2c. This is equation number 43. These two equations are 43. Can you give me any value? By putting the limits. Now you write down sigma r for r is equal to a. In the figure, in this figure, sigma r is equal to radial pressure, radial stress. Sigma r is the radial and sigma theta is the radial. So sigma r for r is equal to a कितना है फिगर में? r is equal to a. Sigma r is pi. If we take one as a minus and the other is the both the pressure he is taking the minus, and sigma r for r is equal to b is r is equal to b external pressure Pe. Now put this value here. Put this value in the 43. What you will get? If you put the sigma r for the r is equal to a, so what you will get? Yes, a upon a upon a square, because r is equal to a for one condition, plus 2c is equal to pi. एग्री हैं आप लोग? फॉर द फर्स्ट इक्वेशन r इज इक्वल टू a, r यहाँ a रख दिया, सिग्मा r क्या हो जाता? पी आई, है ना? हाँ, यहाँ पे r इज इक्वल टू a रखा आपने सब दूर. कहाँ? इसमें दिस 43 में. सो यू विल गेट द पी आई इज इक्वल टू a अपॉन a स्क्वायर प्लस 2c. अब सिग्मा थीटा क्या है? फॉर r इज इक्वल टू b कितना हो गया? सिग्मा थीटा माइनस पी ई. ए अपॉन क्या आएगा? फॉर सिग्मा थीटा ए अपॉन कितना आएगा? r इज इक्वल टू बी स्क्वायर. अब इसको एक में से दो को माइनस करके 2c कैंसिल हो सकता है? equation, there are two equation and two unknown, A and C, two equation and two unknown, 2C. So we can solve and find out the value of A and C. So you will get the value of A. You solve yourself. This is very simple. The question of the 10th class, I think. Two equation, two unknown. Just you 1 minus 2, 2C will get cancelled. So you will get A is equal to A square B square PE minus PI upon B square minus A square, and you will get C is equal to 2C means 2C is equal to PI A square minus PE B square upon B square minus A square. So it is very simple. In the question exam, you are given this, you just write only कि we know sigma r is this, sigma theta is this, and sigma tau r theta is this. You write by heart these three equation. You write this. You find out sigma r, you differentiate with respect to r. For sigma theta, you differentiate with twice with respect to r. So you will get the sigma r and sigma theta. You put the limit. For sigma r is equal to A and B, you will get this. Put this limit and you will get this equation. You solve this, so you will get the value of A and 2C. Substituting this value in the equation 33. आया इतना समझ में कि नहीं आया? कर लोगे एग्जाम में? हाँ? एग्जाम में कर लेंगे क्या? गिव मी द आंसर. हाँ? एग्जाम में आपको ये इक्वेशन दिया हुआ है, आपको ये तीन लिखना है याद करके. सिग्मा आर क्या होता है, सिग्मा थीटा क्या होता है. ये सिग्मा थीटा तो बिल्कुल दो लाइन एक ही लाइन का है. इधर भी यू रिमेंबर दिस, है ना, थीटा. और इसके बाद भी ये सॉल्व हो जाता है. थीटा आर वेरिएबल है तो ये तो कैंसिल हो गया यहाँ पे. सो यू विल गेट सिग्मा आर इज इक्वल टू 1 अपॉन आर डेल फाई अपॉन डेल आर. Here you will get this, and for here you will get the 0, because theta is everywhere. But you should write this equation 3. Then you tell in the case of the one variable r only, you will get the sigma r is equal to 1 upon r del phi upon del r. Sigma theta will get del square phi upon del square, and tau r theta is equal to 0 by putting the theta is equal to 0. Now you will get the sigma r and sigma theta by differentiating this equation. Putting the limit, you will get these two equations. Solving these two equations, you will get the value of A and 2C. Now put the value of this thing into sigma r. So you will constant. So you will get this sigma r. Put the value of A and C. So you will finally you will get, by putting the value in the 43, A and 2C will get sigma r is equal to A square B square PE minus PI. Sometimes it is written outer pressure PO, so don't confuse. External pressure or outer pressure, one and the same thing. B square minus A square 1 upon r square plus pi a square minus pe b square upon b square minus a square. Just put the value of a and 2c and you will get the sigma theta. यही पूछा है क्वेश्चन में कि फाइंड आउट द मैक्सिमम स्ट्रेसेस. a square b square p external minus p internal divided by b square minus a square 1 upon r square plus pi a square minus pe b square minus b square minus a square. You can find this in your Timoshenko book, equation number 44, sigma r and sigma theta. Understood? Huh? Understood
Yes.
or not? Huh. So sometimes the external pressure is 0, outer pressure. If the pipeline is going on the ground with the oil or water flowing in this, so if the P external pressure is 0, only the internal pressure of the water or the oil is there. So you tell me the value of sigma r and sigma theta in the case of PE is equal to 0. What you will get? You give me the answer. Just put external pressure P is 0. PE is equal to 0. If the pipeline is above the ground, there is no outer pressure of the soil or anything, only internal pressure of the water or oil or any liquid. So what you will get? Sigma r and sigma theta. You give me answer. What you will get? Sigma r is equal to from this only. External pressure is 0, only internal pressure is there. In that case, you will get sigma r is equal to, you solve yourself in the fair copy, pi upon b square minus, this is not the question of M.Tech, this is the question of 10th class. So you solve and sigma theta is equal to a square pi upon b square minus a square 1 plus b square upon r square. This is the question of the 10th class. You solve by putting P external pressure is 0. This is the equation number 40. These you write down the conclusion. These equation shows that sigma r is always a compressive stress. Sigma r is always a compressive stress and sigma theta is tensile stress. क्या हुआ? These equations show that sigma r is always a compressive stress and sigma theta is a tensile stress. And sigma theta is maximum, you write down sigma theta is maximum at r is equal to a. Sigma theta is maximum at r is equal to a. So sigma theta max at r is equal to a, क्या आएगा? सिग्मा थीटा में r is equal to a रखेंगे. You replace this by a for find out the value of sigma theta maximum value. So you will get P internal a square plus b square upon b square minus a square. This is equation number 46. Okay. तो एक आपको 12 नंबर का क्वेश्चन मैंने बता दिया है आज. आया समझ में? And try to attend offline class. It is better for you, not for me. It makes no difference for me. I am getting my salary if I am teaching you online or offline, teaching you or not, but it is your point beneficial to you only if you will attend the class sincerely. M.Tech will not come in the future. The marriages and all the functions may come again and again. So don't bother about those function and everything. The M.Tech, if you will do, you are come 180 doing the B.Tech and only 18 are doing the M.Tech. So you comes in the under 10%. If you will do the sincerely, you will, so in the competition you already cut through the 180 minus 18. So 162 people you cut directly by doing the M.Tech. So take it seriously and study hard. It is not, M.Tech is not the matter of any you will sign the big projects being a M.Tech. So be sincere. Okay. So let me finish. What is your attendance is the Sir Ranveer Singh ji and Abhijit and Kunal. Okay. Abhijit, Kunal. Yes, you close. So okay, we'll meet on Monday.
Okay, sir. Thank you. Thank you, sir.
Okay. हेलो, बस क्लास ले रहा हूँ. आया मैं 5 मिनट में पहुँचा. क्लास ले रहा था इधर. ये निकालना थी ना भाई.